Sketch the graph of f of x equal 2 plus log base 3 of x. Now, if we know the graph of y equals log base 3 of x, then f of x simply shift the graph of log base 3 of x up 2 units. We know that the graph of y equals log base 3 of x looks like this. And so if we were to shift it up 2 units, then we just simply bring this graph up 2 units. One important feature of the graph of y equals log base 3 of x is that it has a vertical asymptote at x equals 0, which is the y-axis. If we were to shift it up 2 units, then we still have the vertical asymptote x equals 0. Also, as of now, the domain of the function log base 3 of x is the set of positive numbers only. It cannot be 0. And the range of log base 3 of x is the set of all real numbers. When we add 2 to the function, we only shift it up vertically, so we do not change the domain. What that means is that the domain of the function f of f, which is the function 2 plus log 3 of x, is still 0 to infinity. And the range of the function f, it is still negative infinity to infinity. Although we know what the graph looks like, we should evaluate a few points and plot them. We know that the domain is a set of all positive numbers, so we might want to start with 1, 2, 3, 4, 5, and so on. But remember that 0.5 is also a positive number. 0.25 is also a positive number. And so we might want to evaluate those as well. When we plug 0.25 into the function f of x by replacing 0.25 in x, we have 0.7. Use a calculator. When we substitute 0.5 into f of x, we will get 1.4. When we plug 1 into the function f of x, we have 2 plus log base 3 of 1, but log of 1 is 0, so we end up with 2. When we plugged in 2 into the function, we will get 2.6. When we plug in 3, we have 3 because 2 plus log base 3 of 3 is 2 plus 1. When we plug in 4, we will get 3.3. Plug in 5, we will get 3.5. And so each of these lines in the table gives us an ordered pair. We then plot the ordered pair to get the points. When x equals 1, y equals 2. When x equals 3, y equals 3. Those are the only two nice points here. When x equals 0.5, y is 1.4. And so, there. When x equals 0.25, y is 0.7. When x equals 2, y is 2.6. And when x equals 4, y is 3.3. What happened? When we plugged in x equals 0.1, then we'll get a negative number, and we plug in 0.01, then the y value is negative 2.2. And so we might not be able to plot that point because it is too close to 0. But that is why we have the vertical asymptote. Keep in mind that the vertical asymptote is x equals 0. We will connect these points and form a smooth curve. The graph should stay close to the vertical asymptote x equals 0. This is the graph of y equal 2 plus log base 3 of x. Log is an increasing function, and it is a function, so it passes the vertical line test. And so try not to bend to the right when we go down, because the moment we bend to the right, then it doesn't pass the vertical line test. And so stay close to the vertical asymptote here.